Algebra 1 Lesson 60. We are looking at our products of binomials and finding some patterns with these. One of them that we will look at is perfect square trinomials, which is a product of a factor times itself. So something like a plus b squared or a minus b squared. Well, in order to find this pattern, let's actually look and see if we can come up with it just by seeing some patterns between some of these. Now remember, when we are taking a factor and multiplying by itself, this does not mean that we are just expanding that squared to get 4x squared plus 4. No. We actually need to do 2x plus 2 times 2x plus 2. And in order to do this, we can expand by doing something like rainbows to get 4x squared plus 4x and some smiley faces plus 4x plus 4. And so we see the product of this is 4x squared plus 8x plus 4. Okay? And then on the right side, x minus 5 squared. So we're really doing x minus 5 times x minus 5. So we can expand and get x squared minus 5x, rainbow, or some smiley faces, minus 5x plus 25. So we get x squared minus 10x plus 25. Let's try just a couple more. Let's try this one here. And we will get 16y squared plus 12y plus 12y plus 9. So our final is 16y squared plus 24y plus 9. And this one here, we end up getting 4x squared minus 6x minus 6x plus 9. So we get 4x squared minus 12x plus 9. Now there are a couple different patterns that we want to be able to see here. And number one pattern that we often point out is the fact that when we have a binomial times itself, we end up with this same linear factor inside, the 4x and 4x, 12y and 12y, negative 5x, negative 5x, negative 6x, negative 6x. So when we do a binomial times itself, we end up with this linear term that is our first term, so 2x times 2, so first term times second term, and we have 2 of those. So if we are looking at this more general one right here, that middle term is going to be factor times, or term times term, so a times b, and then we end up always having 2 of those, so we end up with 2ab. So in this case right here, we would get a times negative b, so negative ab, and we have 2 of them, so negative 2ab. Now the second pattern that we see is based on this first term of each. The 4x squared, 16y squared, x squared, and 4x squared. That always comes from taking my first term and squaring it. Okay? So we're always going to take that first term and square it. So in our more general one, we get a squared and a squared. Okay? And then similarly, our last term, 4, 9, 25, and 9, those are actually all perfect squares because they come from taking my last term, 2, 3, negative 5, negative 3, and squaring it. So in each case of our general ones, we get plus b squared, and negative b times negative b is plus b squared. So we see this pattern in every single square binomial that we have. So in this first pattern, what we're saying is that pattern number one, a couple different names, but square of a binomial or square binomial pattern. If we have a plus b, we are always going to square the first term, so a squared, square the last term, and then add to it term times 2. That's how we get this linear term, and that's the same even if we have subtraction in between. The only thing that subtraction actually changes is this negative sign in our linear term. So we're always going to do it like this. We're going to square the first, 2 times the product of the two terms, and the square of the second term. So when we do some of these examples, so for this one, x plus 5 squared, we're going to square the first term, so x squared. 2 times the product of the two terms, so the product of the two is 5x, times 2 is plus 10x, and then square the second term, so plus 25. So you can try all of these, and then I'll show you the answers, but just remember, follow these instructions here, and you will get these answers for each of them. All right, and my second pattern. Let's multiply these out. So I am going to use the box method in this case, let's say. It doesn't really matter which one I use, but I say 3x plus 4 and 3x minus 4. Looks pretty similar to what we were just doing, except that we don't have the same sign in between our terms. But we do have the first term the same, second term the same. We just have it in addition and subtraction. So we get 9x squared, we get 12x, negative 12x, and negative 16. Which means the 12x and negative 12x end up canceling each other out, and we end up with just 9x squared minus 16. Second one, let's try that. We get x, 6x, and negative 6, so x squared, 6x, negative 6x, and negative 36. Once again, these get canceled out. So we get x squared minus 36. And last one, let's see if we can do it based on the pattern that we see in the first two. But when we look at these, both of them ended up with the linear term canceling out. So the 12x and negative 12x, 6x and negative 6x. So when we do this, we end up just squaring, or actually multiplying our first terms together, so we get x squared, multiplying our second terms together, 6 and 6, and subtracting them. What we call this is a difference of squares, because 9x squared, 16x squared, and 36 are all perfect squares, and we are finding the difference. This comes when we have the first terms the same, second terms the same, and we are adding and subtracting in one and the other. So in our next one, we're really actually just, all we have to do is say, I'm going to square my first, square the second, and subtract between the two, because we know that linear term is going to go away. So this is the pattern, pattern number 2. It's called sum and difference pattern. I call it difference of squares. But when we see this pattern, we don't have to FOIL, because the answer is always square of the first minus square root of the second. So you can try these examples on your own, so you can pause the video and try them out. But you should get these answers: x squared minus 9, r squared minus 9, 16x squared minus y squared, x squared minus 100, 4x squared minus 1, x squared minus 9y squared. Okay? Here are some other examples. Remember, use your the different patterns that you have. So let's try this middle one. And here we have a square binomial. So we're going to square the first, so 4x squared. We're going to multiply the two together, so we get negative 14x, and times 2, so negative 28x. And then negative 7 squared is a positive 49. Okay, so use those patterns. And in this one, let's say we do the second one on here, 4x plus 3 times 4x minus 3. This is a difference of squares, so we get 16x squared minus 9. That's it. That's all I have to do. Okay. Now, what's kind of fun about this is the fact that we can use some of these to do some really simple mental math. So, if I were to ask you to do 39 squared mentally, it may not be that easy. But if we use our product patterns, it becomes a little bit easier. And how we do that is by saying 39, well, I can also describe that as 40 minus 1 squared. So using our patterns, we can say, well, that's just a square binomial. So I'm going to square the first. So 40 squared is 1600. I'm going to multiply the two together. So 40 times negative 1 is negative 40, times 2 is negative 80. And then square the last one, so plus 1. And 1600 minus 80 is 1520. plus 1, we see that the square of 39 is 1521. Okay? So kind of fun to mess around with the numbers like that and look at them in a new way. And how about this one? 16 times 24. That's like saying 20 minus 4 times 20 plus 4. So I could do this by squaring the first numbers, so 400, squaring the second, 16, and subtracting the 2. So we get 384. 16 times 24. Okay? And we'll just do a couple of these. Roberta has a garden in the shape of a parallelogram. Remember, we find the area of a parallelogram by doing base times height. So the height is x minus 2. The length is x plus 2. So find the area. All we have to do is use our difference of squares to say this is x squared minus 4 feet squared. That's it. Okay. Another one, we have the 6-foot deck around a square house. The side of the house is 7x feet. So find the area of Marcus's house, including the deck. So we're really, I'll draw a picture of this. We have this house, the square house, that's 7x by 7x. And if we do a deck around, this is going to add 6 on each side. So 7x plus 12. And it's square, so we're going to square it. So in order to do that, we can use our patterns to say, all right, I'm going to square the first 49x squared, multiply the 2 together, so 84x times 2 is 168x plus my last one squared, so 144. And we have that as feet squared. Okay? And you can try this last one on your own. Find the area of the garden using our different formulas. Okay, this should say we have the same variable here, so there should be x plus 6. Well, I hope this is helpful for your homework and for studying.